All right, welcome everybody to Standing for Truth. My name is Donny, and this video is going to focus on debunking Gutsick Gibbon on the Y chromosome. Does the Y chromosome really support human evolution? And this is going to be a comprehensive series of videos. It'll probably be about 3 parts, as it is a comprehensive, it's a technical and very important topic. And so I want to make sure that I go through Erika's entire video point by point, sentence by sentence, and give my thoughts, my considerations, and my overall response on the matter. And so that'll probably take a few different parts. As a matter of fact, the beginning portion of this video, I do want to focus just briefly on the topic of dating methods and accelerated nuclear decay. Now, before I get into that, which again is going to be the first portion of this video addressing Gutsick Gibbon, we've put out several videos addressing her arguments against young earth creation, against biblical creation, and for evolution and an old earth. And so I do recommend people check out my comprehensive response to Erika on junk DNA, chromosome 2 fusion, and also most recently the heat problem, where Matt and I both responded, and we responded extensively to her video on the heat problem and supposedly why or how the heat problem is the death of creation science. So make sure to check out those videos. We went back and forth a while ago on the chromosome 2 fusion. I was very thorough. I did a point-by-point response for the most part with Brian from Apologetics 101, where he played her video on junk DNA and chromosome 2 fusion. And I gave my response. I gave my counters. And again, I was very thorough on the matter. And so on those topics, the ball is in her court, the topics of junk DNA and also chromosome 2 fusion. Now, she's put out a video on the Y chromosome and supposedly has provided an answer to the Y chromosome challenge that I have been offering or advancing for the last several years in videos, debates, interviews, discussions, open mics, and so on. And so with that, guys, let's get right into our first topic at hand for tonight, which is going to focus on radiohalos, Dr. Andrew Snelling, and accelerated nuclear decay. And so I want to play her video. We'll briefly comment on it and then provide a response from Dr. Andrew Snelling himself, since that is who she is critiquing in her video. So here we go.
Lorence Collins has studied radiohalos extensively and has shown some solid work that radiohalos actually can and do occur in nature, without the need of a global flood, I mean. Collins reports that the granite that contains polonium radiohalos is not primary that has crystallized from magma, but is a secondary chemical replacement product in which former already crystallized plutonic igneous rocks, which are presently below 450 degrees Celsius, such as diorite, have been microfractured such that hot water or steam can move through the rock at temperatures below melting temperatures that subtract iron, magnesium, aluminum, and calcium from such a rock at the same time.
Before she continues, I just want to comment briefly on this issue of accelerated nuclear decay. So Matt and I, we put out some detailed responses. We actually did a response, more of an abridged version, a shorter version with Kent Hovind, and we discussed whether or not accelerated nuclear decay during the flood is necessary, because we understand that that kind of accelerated decay during that year-long period would create a lot of radiation and heat. Approximately 500 million years plus of decay would have occurred in that year's time. Now, there are several lines of evidence provided for accelerated decay, 2 of which in particular I find very interesting and compelling, which include radiohalos and helium. So we've discussed helium in great detail. We've also discussed radiohalos basically being these microscopic damage, microscopic pieces of damage in the rocks that appear to suggest that decay has happened, but decay at an accelerated rate, okay, due to this damage. And the critics have a problem with those lines of evidence, mainly because they argue, again, if there was that much radioactive decay, then there'd be too much heat and radiation, and that would destroy the earth, destroy the arc, destroy nova, vaporize the ocean. And so they see a problem with this. And therefore, Matt and I, we again spent over 2.5 hours providing alternative explanations that do not involve a lot of accelerated decay. We do propose a little bit of accelerated decay, which fits nicely in line with the helium that we find in zircon crystals and rocks that are supposed to be billions of years old. Again, just to recap, helium is a very slippery molecule, and it should have leaked out into the atmosphere of these rocks that are supposedly a billion plus years old, because we do find a lot of lead in them, and the byproduct, the result of uranium decaying into lead, parent to daughter isotope, there is helium. And we still find a lot of helium. And so those who hold to accelerated nuclear decay, like the rate scientists, they argue, well, we have a lot of lead, which tells us that there's been decay from uranium to lead, but we also find a lot of helium. Okay, so we find a lot of decay, which might suggest billions of years, but then we still find a lot of helium. So if these decay processes have been occurring for millions of billions of years, then all of that helium should be gone, especially at high temperatures, deeper in the earth. Then the helium would leak out quicker, from my understanding. But the fact that there's still a lot of helium and we find a lot of this lead, the daughter isotope, then there's a lot of decay, but it would have had to occur in a short amount of time in order for there to still be helium, right? Pretty simple to understand. Okay, some would interpret that as accelerated nuclear decay, and it is compelling. But Matt and I, again, we did a video, and we proposed an alternative model that does not require that much accelerated decay. And as a result, we provided solutions and answers to the so-called ordering of these isotopes in the rock strata, the answer to why rocks that are found deeper apparently age or date older than rocks at the top. Okay, so we did a whole video on that. I'm not going to recap that here. And also explains what we see in general without accelerated decay to the point of 500 million years in a year's time span. And so that way we can provide alternative solutions to heat and radiation if accelerated decay of that magnitude is not present. Okay, but those that hold to accelerated decay, or those that want to hold to accelerated decay, we can challenge, because I do believe in multiple working hypotheses. And so we can challenge the critics to not just hand wave away this evidence, radiohalos, helium, and zircon crystals, but to actually engage it and to refute it. Because someone like Dr. Andrew Snelling, PhD geologist, he understands these things. And this has been a big study of his into radiohalos. He argues that if there was as much heat and radiation that the critics argue was there because of the Genesis flood, then there shouldn't be radiohalos, because radiohalos are obliterated at relatively high temperatures. So the fact that we have radiohalos and the radiohalos seem to suggest accelerated decay, then that means there must have been some kind of supercooling mechanism going on during the flood, whether supernatural or natural, to explain why we still have radiohalos, which are evidence for accelerated decay according to this model and proponents of it. Okay. And so here is Erika's response to the radiohalos as evidence for accelerated decay. So that's a little background information on that.
Inducing silica and potassium to convert the rock into granite. His model of this process was published out of his university in 2014. During this process, uranium in scattered crystals in the rock is continually releasing radioactive radon and polonium ions so that this radon and polonium can diffuse through grain boundary fractures and into the fractured biotite crystals. To be clear, steam is not transporting the radon, it is naturally diffusing. The creation of a polonium radiohalo then only requires a nucleation site to form in the core of a halo, and the progressive growth of this core by the addition of incoming polonium will eventually produce more than 500 million atoms in the tiny core that will produce a recognizable dark halo in the adjacent biotite lattice. This diffusion may occur over, say, 10,000 years or more as repeated earthquakes fracture the rock and keep the rock an open system for diffusion of elements. Put simply, polonium radiohalos can only form in granite created by chemical replacement processes at temperatures below melting conditions. However, polonium radiohalos can form in granite pegmatites where uranium is concentrated in water-rich accumulations that allow large biotite books to form during the late-stage crystallization of granite magma. Snelling's model also fails on its own.
Okay, so this critique, largely put forth by Dr. Lorence Collins, is his name, from my understanding, a retired geologist. Here is a critique that he's done that you can find: radiohalos, solving the mystery of the missing bullets, origin of polonium halos, revisited. And so Lorence G. Collins, you can find this, you can find the critique. And so apparently, according to Collins and Erika, these radiohalos can be formed without accelerated decay processes. Now, if that's true, if Dr. Andrew Snelling has been adequately or sufficiently addressed, encountered on his work, that's fine, because again, we believe and hold to multiple working hypotheses. That's the right way to do these things and to go about doing science and building a model building. We've already presented, Matt and I, a comprehensive model that does not require the kind of accelerated decay that is proposed by various proponents or advocates of it. But we still need to look into this thoroughly. We need to do a deep analysis and see if this argument or supposed counter really does work, if it is sufficient. So apparently it can be done without these kinds of accelerated processes. Collins argues that the granite that contains these polonium radiohalos, the granite is not primary, and it is a secondary chemical replacement product. And he again has a lengthy critique here, but basically argues that Dr. Snelling's work here is flawed. And so let's have a look at Dr. Snelling's response to Lorence G. Collins, and let's see what his thoughts are.
In Ontario, that doesn't, that's where you have concentrated uranium ore deposits in calcite veins and dikes. And that's different. The granites that I've been looking at, he's talked about this idea. He'd be a good one to ask, definitely.
Okay, here's where my question is presented to Dr. Snelling. This was recent, a solid presentation in Q&A. I highly recommend people check it out. It's probably the most up-to-date lecture and talk you're going to find on this issue. So if you are invested, I highly recommend you check this out. Not just this section, but the entire lecture and video presentation itself, including the Q&A, which is thorough. And so I presented this question to Dr. Snelling in response to Erika's video, and specifically her primary argument there.
So got another question here first from Standing for Truth. Are you familiar with the arguments made by Lorence Collins and Ken Wolgamuth, who argue that polonium radiohalos can be formed without accelerated decay processes? And one example, I was just reading an article earlier today. One of the arguments I believe Collins makes is that you can have these calcite dikes, and you can get radon atoms without uranium, and then you get polonium from those radon atoms. So are you familiar with these counter arguments?
Yes,
Any thoughts?
I am familiar, but of course,
These criticisms and objections to Dr. Snelling's work are not new. These PhD creationist scientists, they are familiar with these criticisms. Dr. Russell Humphreys, who made several incredible predictions, many of which have come true. He's pointed out in one of his recent talks on helium and zircon crystals that he is unimpressed with the criticisms and objections to his work, to these amazing findings with helium in these rocks that are supposedly millions to billions of years old. The helium shouldn't be there. And so the critics, they put forth counters, they put forth rescue devices, and they're simply weak. A lot of times they're repeated. And again, Dr. Humphreys points out in his recent talk here, comprehensive talk, that the critics really have failed over the years. And occasionally they'll come up with a new argument, and that new argument also fails. But typically it's by, one or two people or the same person over and over again, but they're not publishing anything worthwhile to actually respond to this data. So these creation scientists, they are aware of these criticisms, as you could tell with Dr. Andrew Snelling's reaction here. He is not surprised by any means. He's not caught off guard. He's familiar with these supposed counters.
of course, that's an example that's grabbed from the Bancroft area in Ontario. That doesn't, that's where you have concentrated uranium ore deposits in calcite veins and dikes. And that's different. The granites that I've been looking at are regular garden variety granites.
Notice what he says there about his work and what he's looking at. The granites that Dr. Snelling is studying and analyzing are regular garden variety, as he said, granites. Okay. And so there's something that needs to be considered by the critics.
That, yes, okay, you got quartz veins with metals in them for ore deposits, but there's nothing, no major uranium deposits, no
major uranium deposits,
concentrations. The only time
no real massive concentrations
that Robert Gentry found unusual numbers of radiohalos and unusual radiohalos are in those sorts of situations. For example, the Wolfendorf fluorite in the Schwarzwald area of Germany was in a uranium associated with uranium, and so was the calcite vein dike at Bancroft in Ontario. And so those are unique situations. All the examples that I've shown in this presentation are regular granites.
So I'd recommend the critics, if they want an up-to-date lecture or presentation on this issue, they should watch this one. I'd recommend that they watch Dr. John Baumgartner's recent presentation on C14 found in diamonds, because right there's fascinating data, incredible evidence for young Earth, and the best criticisms or objections to the C14 found in diamonds have been addressed thoroughly. There are just some mind-boggling assertions coming out from the critics. Some critics saying, oh no, there's no C14 found in diamonds. I mean, just clearly not up to date on the data, not up to date on the controversy. And so really, creation scientists like Dr. Andrew Snelling, Dr. Baumgartner, Dr. Russell Humphreys, you can see why they're not impressed with the so-called best counters and rescue devices that the critics have to offer. Because here, Dr. Snelling seems to be making it pretty clear that Collins and Ken Wohlgemuth, I think is his name, is another one, from my understanding, a geologist. They are looking at unique situations. They're taking these extreme examples that Dr. Snelling is not even presenting as a basis for his model. So it does not appear to me in my analysis of this ongoing debate or feud on the matter, on the issue, that Dr. Snelling's model is actually being engaged in a sophisticated manner.
And neither Lorence Collins or Ken Wolgamoth have been able to grapple with these sorts of granites.
So apparently these sorts of granites that Dr. Andrew Snelling is looking at, Collins and Wolgamoth, both of them are not able to contend or grapple with this. So it goes unanswered.
Let's talk about the Tuolumne intrusive sweep in the Yosemite National Park. There's no concentrations of uranium or like that, or special conditions.
So no massive concentrations there of uranium, no special conditions. And so let's see if, and maybe they have, but it doesn't look like it. Let's see if they've engaged that or interacted with, again, what Dr. Snelling's actually presenting for the basis of his model here.
These are regular garden variety granites, and yet we can see where you go from one granite intrusion to another in the sequence, in the nested sequence, that there's no heat effects by the later ones on the earlier ones, and yet you get increasing volumes of hydrothermal fluids and increasing numbers of polonium radiohalos, just as the polonium radiohalos by hydrothermal fluids model transport model would predict. And so that's my response to Lorence Collins.
Just as the model would predict. So here's a response from Dr. Andrew Snelling. Let's see Dr. Lorence Collins respond, or let's see Erika respond.
And to Ken Wolgamoth. They've taken extreme examples that are not the ones that I'm presenting as the basis for my model.
So according to Dr. Snelling, they're taking extreme examples that are not the basis, or it's not what Dr. Snelling here is presenting in terms of his model. And so again, we have multiple working hypotheses. Do you have to go with accelerated nuclear decay? No. And Matt and I, we've put forth what we believe is a very powerful model that has a lot of explanatory power. Or you have a model that suggests accelerated nuclear decay. And as Dr. Snelling has pointed out, with the radiohalos, if the existence of these specific radiohalos are evidence that accelerated decay has happened in the past during the flood, then there must have, by definition, been, as a result, a way to supercool these rocks in the earth, or else those radiohalos wouldn't be there. So that is a powerful line of evidence. And so it is up to the critic, like Gutsick Gibbon, to adequately or sufficiently address this evidence, to address in a sophisticated manner, in a detailed manner, Dr. Andrew Snelling's model. And it does not look like Collins or Wolgamoth have. And okay, this is not my active research project. I am not an expert on this specific issue and Dr. Snelling's work and model here by any means. But as we can see here from Dr. Snelling himself, more than qualified to speak on these topics, he is dissatisfied with the critics. Okay, so we'll leave that there, and we'll see if any discussion comes out of that. Okay, so our next major topic is going to be a response. This is just going to be a brief response because I'm going to do this in parts, and I want to make each part digestible. I don't want them to be 2, 3, 4 hours long, maybe roughly an hour long for each. So we're going to begin our response to Erika's video on the Y chromosome and how the Y chromosome supposedly supports or confirms human evolution and demolishes separate ancestry, or the biblical model of ancestry. So let's have some fun with this. And I have gone through her entire video. And so I am going to respond and debunk the major points in it. And again, we'll do that over the course of a few videos. And I have other videos of hers that I am going to debunk next as well, those on transitional fossils and homology. And I'm also doing a series responding to Stated Clearly. John Perry from Stated Clearly on endogenous retroviruses. According to him, I think it's 11 reasons he puts forth why ERVs really are the ancient remnants of past viral infection. And I am going into part 4. So we got a lot of different series and projects that we are working with. So bear with us as we do our best to get these video responses out. And so, okay, let's have some fun and start her video here. I will say my response, I want it to be bare minimum in terms of doing slides and visuals and just an all-out presentation. As anybody who follows this channel knows, I have done several presentations on ancestry and biblical creation in general. You can find endless slideshow presentations from myself. I just recently spoke at Kent's boot camp in July twice, and those were comprehensive. One of them was on the incredible evidence for Adam and Eve. The critics have not responded to those presentations, and so those presentations, the evidence presented in them, including the data, the technical papers, have not been addressed. So for this one, I want to keep it a little more free-flowing, a little more organic, as I play a few of her words and then pause and respond. And so let's get into this, guys.
Oh, my gentle and of course very modern apes.
And this is why we're going to do this over the course of a few videos, because her video is an hour. And we are going to play every last word. I don't want her or any critic to say that we are not responding to every single point and just her video in its entirety. I want them to, and you guys as well, to see that we are leaving no stone unturned. We're not hiding from anything here. Okay. And one thing I do appreciate about Gutsick Gibbon is, firstly, she's clearly informed on these issues. And so she makes it a lot more fun to engage and a lot more fun to watch her videos, because she's putting in the work, she's putting in the time and effort to engage and interact on the topic of origin, specifically young earth creation. And that is contrary to what I see with a lot of the other bigger YouTube channels. So I've done full video responses to people like Simon Dan. He put out a video relatively recently on on Adam and Eve and why the scientific evidence does not support the existence of Adam and Eve. And I did a full response, responded to the entire video, point by point, word by word. And of course, he does not put in the work necessary to rebut me or engage those points. And that's okay. He can't. A lot of the bigger channels are looking to people like Gutsick Gibbon anyways. Okay, because they're kind of just repeating talking points from people like Gutsick Gibbon or Dr. Dan Stern Cardinal. They're in many ways the bosses of evolutionism. Okay, if you want to consider it that. And so when you refute people like Erika or Dr. Dan Stern Cardinal, you refute everybody with them, the ones that are just repeating their talking points. I've done full responses to people like Paulogia, for example, on the chromosome 2 fusion. Paulogia, this is going back probably a year ago. He argued that chromosome 2 fusion is the best, most irrefutable line of evidence for evolution and ERVs. And so I responded to that in detail. And of course, he refuses to put in the work necessary to defend his assertions, to defend his points. And so they can be a little bit boring to interact with because they simply can't contend. But at least Gutsick Gibbon, she puts in the work to contend and to have a meaningful dialogue, back and forth interaction here. So this is going to be good because she is at least putting in the effort to address this challenge, this Y chromosome dissimilarity challenge. I've been using it on evolutionists. It's a fantastic line of evidence for years now, because when you consider overall gene content, size differences, and architecture, the human Y and the chimpanzee Y are only about 35% the same, even less now after the new papers that have come out. And so typically your evolutionists, including your evolutionary scientists, they will concede. They'll tap out. They don't have an answer at this point. They don't really know. And the hypotheses in the conventional literature are largely untested. So there's not really all that much that they can go by. And so it is I am appreciative over the fact that Erika has at least provided a response that we can get into and have some fun with.
I'm filming kind of up on my desk because lately I've been enjoying filming here when I need to like navigate papers and type on my computer, because I normally put my computer when I'm recording back on my set on like a little pushy cart, which is hard to type on. For the most part, I'm still going to record back there, but when I need to like get through papers, I'm going to record here. I also like that you can see the whole shelf. Normally you don't get to see the whole shelf. You don't get to see the wonderful bovid skull that I have up there at the top, or the mini hominins that I have here at the bottom that aren't in my primary lineage here. I don't know why I'm telling you all this. Why indeed is the question. Why chromosome is the question. We're talking about the Y chromosome today.
Now, the Y chromosome, I want to say, getting into this, it is an important chromosome to look at because it is uniparentally inherited. It's paternally inherited. So your Y chromosome, you get on your father's side. So I got my Y chromosome from my dad. My sons got their Y chromosome from me. So it's only passed down on one side, the father's side. Okay, that's why a male is XY. But your other uniparentally inherited DNA compartment is your mitochondrial DNA. Okay, so these DNA compartments lack recombination. The Y chromosome seems to be a little bit at the tips, possibly gene conversion, but for the most part, there's no recombination where the chromosomes are lined up and genetic information is exchanged between the chromosomes. Okay, these chromosomes are shuffled. That's how you get novel chromosomal combinations every single generation. That's why a couple could hypothetically have 1 million kids and every single kid will look different because we have pre-existing DNA variants that are recombined or shuffled every single generation to create novel chromosomal combinations, which creates variation, incredible variation built in. Okay, so this is important because the Y chromosome lacking recombination would suggest that the Y chromosome should be relatively stable compared to the other chromosomes. Okay, your autosomal nuclear DNA, autosomal, that's biparentally inherited DNA, there is recombination. There's genetic shuffling every single generation. So it's going to be a little more messy because there's some scrambling taking place. And so one might expect before the data came about, because from my understanding, the evolutionary community did not predict the data derived from these sophisticated Y chromosomal analyses. And I can ask Gutsick Gibbon that. Was this predicted ahead of time, or is this just a lot of post hoc, ad hoc explanations or rationalization? And so if it wasn't predicted, it could be the case that the understanding was, if we're dealing with non-recombining uniparentally inherited DNA here, that it would be more similar. Okay, so there is a difference here between something like the Y chromosome, which is autosomal DNA, which is nuclear DNA, not autosomal DNA, and autosomal nuclear DNA. Okay, so let's continue here.
So a little bit of background, I'm going to be as brief as I possibly can be. In conventional science, humans are thought to descend from a more basal ape roughly 7 million years ago. And that's the common ancestor that we share with chimpanzees, the panins, our closest living relatives. So what that means is that if human evolution is true, we should share an immense amount morphologically and genomically with these guys, with chimpanzees and bonobos. This is in contrast to the creationist, or specifically the...
Now, at the same time, if you were to look at a human and a chimpanzee, compare a human and a chimpanzee, even just before complicated genetic sequencing technologies came about, okay? Advanced genetic comparisons. You stand back and look at a human and a chimpanzee and then bring in a dog or a fish or a bacteria or an elephant. What do we, just on the outward appearance, look a lot more like? Okay, that's why you can read about this great chain of being, okay, even before Darwinism was promoted, because people have recognized that, yes, creatures in the biological world have things in common, have a lot in common. And so you take any creature in the biological world, and that creature is going to share more with another creature and less with a different creature. And so whatever creature you could take a bird today and perhaps conclude that a bird looks most similar to a theropod like dinosaur. So similarities don't equate relationship. It's just that we're all made of DNA, RNA, proteins. We share similar phenotypes, especially because we have the same underlying building blocks. Okay, so you stand afar and humans are going to look a lot more similar to a chimpanzee than they will to a dog or a fish. Anybody's going to conclude that. And so one could conclude on a DNA level, the blueprint is going to be a lot more similar as well, even before those results or even before that data has been manifested in more so recent times. Okay. Tell a kid to go to a zoo. If you're in the zoo, tell your kid, your son, your daughter, whoever, to go around the zoo and pick out the animal that they feel they look most similar to. And chances are, strong chances are, they're going to point to a chimpanzee if there's a chimpanzee in the zoo, or a gorilla. And they're probably not going to point to a giraffe or a zebra. Okay. So again, even before this creation versus evolution debate controversy over the last 100 years or so, okay, people have always recognized that there are similarities in the biological world. And you can look at a chimpanzee and you can say, okay, humans look a lot more like this creature than they do to this dog or this fish.
Young Earth creationist proposal that humans are like these distinct creations set apart from the rest of the animal kingdom, and that the rest of the animal kingdom fits
Set apart in the sense that they are a special creation created independently from any other form of life. Our starting point being Genesis. Genesis claims to be the history book of the universe. Genesis makes it clear about our origins that God created two people, Adam and Eve, separate from any other form of life. There's no hint of human evolution. There's no hint in Genesis that humans are related to chimpanzees. But that doesn't mean we would argue or have ever argued, as far as I know, that humans are separate in terms of having different building blocks. No, humans still have DNA. Humans still have RNA, having proteins. You would need an entirely different suite of building blocks, as if humans are an alien from some other planet. And so they're not made of the same building blocks and elements and underlying genomic materials as other forms of life. That's the only way you're going to have humans sharing 0% of anything with the biological world. And so sometimes militant evolutionists like Aaron Ra, they appear to be putting forth or proposing a very unrealistic challenge, like the phylogeny challenge. You're going to be able to fit humans and any creature for that matter somewhere in the biological world. Just like you can pick any car on the planet that's ever been designed by man, and that car is going to be more similar to another car. Okay. Or another brand of car in the world of modes of transportation. And so it's the same thing with the biological world. Look at a dog, and your dog is going to be more similar to one creature and less similar to another. So just naturally, you're going to have these groups within groups patterns. It's not like you're going to have humans just completely separate here, sharing 0% of DNA, RNA, proteins with every other form of life. No, humans are going to look more like a chimpanzee, and they are going to look less like a dog or a fish.
neatly into these created kinds, these baramins. You might be new here, so allow me to explain just very briefly. Created kinds, the baramins, are this idea, usually within a young Earth creationist context, that in the beginning, roughly 6,000 years ago, God creates these archetypal kinds. And these kinds can beget a lot of diversity that ends up being responsible for all modern diversity and also the diversity that we see in the fossil record, but the kinds themselves are not related to one another. So for instance, God might poof an archetypal felid, a cat, into existence, and that means that all living cats and fossil cats descend from that cat, but none of those cats are related to any dogs, and the dog might be a separate archetypal creation. In this context, right, God creates humans, and humans are one thing, and the rest of the apes are like another.
I would say that's a pretty good explanation, and I would argue that the best definition for a kind is groups of organisms that can be traced. So in our baraminological analyses, okay, groups of organisms that can be traced back to a common ancestor, they belong to the same kind, and that common ancestor, especially if it's the original archetype, either at the flood or at creation, that common archetype is unrelated to other archetypes that groups of organisms can be traced back to. And I would argue, and I have argued in my presentations and talks on this issue of ancestry, universal or separate ancestry, that we can do that with humans, and we have done that with humans using the Y chromosome, which is why this is so similar. Let's see if Erika really has addressed that challenge. Looking at DNA function, looking at linkage blocks. Okay, that's an important one. Orphan genes have no real consistent hierarchy, and the explanations for the existence of these taxonomically restricted and essential genes are largely just imagination and storytelling, like de novo gene synthesis. Very much circular. Why do orphan genes exist? These taxonomically restricted and essential genes. Oh, that's because of de novo gene synthesis. Well, why is there something called de novo gene synthesis? Why is this a thing? Well, because we have orphan genes. So it's very circular, but that's a topic for another day. Anyway, so the point is, that's my definition. And so if the created kind model is true, then we should be able to take a group of organisms that exist and fossil ancestors and trace them back to a common ancestor that's unrelated to other groups of organisms that go back to their common archetype. We can do that with the mitochondrial DNA as well. Mitochondrial DNA of humans compared to chimpanzees, very, very dissimilar. Okay, so let's continue here.
Other thing, or maybe he has like a pan-in kind, like the chimps and the bonobos, and then one for gorillas, and then one for orangutans. And obviously, right off the bat, that's weird, because who would look at...
And with created heterozygosity, which is the model we propose, design diversity, which makes predictions, and again, that's a whole topic for another day, but that goes back to basic genetics. Okay, you got capital A, lowercase a, capital B, lowercase b. At that genetic loci or location, you'd be what? In that instance, you're genetically heterozygous. If you're genetically homozygous, you'd be capital A, capital A, capital B, capital B. Okay, God said to be fruitful and multiply, not to be fruitful and clone yourselves. So theologically and scientifically, it makes sense that God would have created Adam and Eve in the original created archetypes or kinds with pre-existing DNA differences. And so then it's easy to generate diversity for creatures to adapt, for new novel chromosomal combinations to come about. Okay, as she's saying, let's say you have an arc-phelid archetype or an arc-canid archetype. Okay, so they come off the ark. They've got those front-loaded DNA differences. Makes sense that God would have sent the most heterozygous pair of creatures onto the ark for propagation purposes. Okay, and so from there, let's take the canid. From there, with those pre-existing DNA differences, you can get your wolves, your coyotes, your dingoes, your domestic dogs. Okay, very simply because those DNA differences are already built in. So you don't need millions and millions of years for mutations to add the necessary kind of genetic variation or genetic diversity for selection to actually act upon. No, that reservoir of DNA variation is already present.
Chimpanzees, orangutans, gorillas, and suggest that none of them are related, but I digress. This is important for what we're talking about today. Creationists have long been up a creek with regard to the morphologic similarity that humans share with the rest of the apes, right? We have all of the primates synapomorphies, all of the catarrhine synapomorphies, all of the ape or hominoid synapomorphies, and all of the great ape or hominid synapomorphies. That lands humans physically, with regard to our bodies, firmly in the great ape family of hominidae. And to make matters worse for them, we see
when it comes to common traits, see, a lot of this comes down to classification systematics in general. Right? Everybody's familiar with kingdom, phylum, class, order, family, genus, species, Linnaeus classification. Well, we can do the same thing with our books. If you go look at my bookcase, especially upstairs, I will have my books laid out or organized in very specific categories. You'll find groups within groups in my book collection. And so I might have my theology books over here, but then within theology, I got my soteriology books and my eschatology books over here. In my science books, I could have my books on genetics here, my biology books, creation versus evolution books, geology books. Okay. You could have a category of the flood, the Genesis flood. And then within that, a lot of smaller books dealing with geology related topics. Okay. So yeah, you can categorize things, especially if you want to make a circle. You make a circle big enough, depending on the title you give it, things that breathe. Well, now you're going to have all forms of life. Okay, so yeah, you have all of these classifications, these traits that you can look to. Okay. And by looking to those traits, looking at similarities and dissimilarities, you can group humans in with the great apes. You can group humans in to the primate family. Okay. You can group them into the mammal category. You can say they're animals. Okay, I'm just talking about taxonomy. And so this is what taxonomists do. But again, these similarities do not equate relationship. And that's why I like to say, and we're going to spend a lot of time in this series talking about how it is not necessarily the similarities that are going to help answer this question of ancestry. It is the dissimilarities, because it is the differences that make all the difference. So remember that. It is the differences that make all the. Okay, so let's continue for a bit longer here, as again, I want to keep these about an hour just to make them digestible. And we'll probably finish the series in roughly 3 parts. Here we go. But do remember that it's the differences that make all the difference.
The emergence of the unique human characteristics emerged through geologic time in the hominin fossil record. So this is something that's been recognized since Linnaeus, right, the father of all taxonomy and a creationist himself, who well before Darwin recognized that humans and the rest of the apes share a lot in common, more in common than some other groups that he would argue were also patently related, and even reluctantly said, "Yet man does recognize himself as an animal. But I ask you and the whole world for a generic differentia between."
That's right, because we all have similar morphology, anatomy, physiology, and genetics. Of course, humans are not alien. Humans did not come from another planet. We have similar building blocks, which actually makes sense. The Bible says that man was created out of the dust of the ground, very similar elements in the entirety of the biological world.
Between man and ape, which conforms to.
But again, that's why the differences are what need to be focused on, because the similarities are largely agnostic to the overall debate of ancestry. The similarities, both models can, generally speaking, account for them. So homologous patterns in anatomy, homologous patterns in the genome, the genomic systems of biological organisms. Evolutionists are going to say that those were inherited from past common ancestors. Descent with modification. Similar structures passed down over time, and they're modified. Obviously, as time goes on, in the genome, you accumulate mutations and DNA differences. And in terms of morphology changes. Okay, descent with modification. But the creationists will say that homologous patterns are there due to common design purposes. Man and human engineers build in homologous patterns. Why shouldn't God? Okay, so it's largely agnostic. Now, I would challenge the evolutionists, though, and they think they've answered this adequately, but they haven't. Why are there such high degrees of similarity in the first place? Was this predicted by the evolutionists? I don't know. You tell me. Because if evolution's true and we've been changing and adapting and accumulating large amounts of mutations and genetic variation for millions of years, then all of that should have wiped out the signature that we see. It should be a weak signal of homology, not this high degree of homology. There should be a lot more differences if evolution's true, because you have millions of years of mutations altering genomic systems and morphology being modified as well. Okay, so why the high degree of similarity in the first place? And again, I know they've provided their answers, like Dr. Dan Stern-Carter now, but we've responded to those.
To the principles of natural history, I certainly know of none. If I were to call man ape or vice versa, I should bring down.
Even in the similar sequences, let's say we were to compare chimpanzee and human genetic sequences, the similar sequences have differences in gene regulation, differences in gene expression, that process by which a gene is turned on to produce a functional RNA or protein. Okay, differences in epigenetics, differences in the 3D architecture of the genome. And the evolutionary community, evolutionary scientists just say, well, since the split, this is where these differences have accumulated. This is where these differences in function have taken place. But a lot of that is just storytelling. It is trying to explain this data after the fact. It is trying to explain these differences in, let's say, function and epigenetics and the 3D architecture of these genomes with those evolutionary presuppositions.
All the theologians on my head, but perhaps I still should do it according to the rules of science. But with the 21st century came the advent of
Creationists, from my understanding, there were some creationists going back 100 years ago or so that believed in fixity of species. Okay, that's easily refuted and that's easily demonstrated to be false. Ever-changing environments demand ever-changing genomes. And the Bible does not teach fixity of species. And so the second we understand that species change, that God created species and biblical kinds to change and adapt, then you know what? Everything that Charles Darwin wrote in his book is now evidence for creation. Thank you, Darwin. Because really all he demonstrated was adaptation and change. We're not against change. We're not against changes in allele frequencies and populations over generations or over time. We're not against that. Species can change. And there are a variety of sophisticated mechanisms that allow for that kind of change.
genetics, and it is here that the creationists placed their hope. Maybe there was something internal about the DNA that separated humans from other apes, something that made them distinct. And then the human and chimpanzee genomes were sequenced.
Well, it's not only that. If you were to look at the evolutionary tree of life, this hypothetical tree of life, where you've got no living organisms, so you've got non-living chemicals, which are supposedly abiogenesis. They're supposed to chemical evolution. Okay, somehow they're going to have to form and evolve into the first self-replicating molecule. And then from your first single-celled like ancestor, you go into a multi-celled ancestor, into a fish, amphibian, reptile, mammal, so a primitive mammal, up to man eventually. Those are some massive changes that need to take place. Do single-celled like organisms have eyes, legs, arms, brains, circulatory systems, endocrine systems? Are they sophisticated in their makeup like human beings? No, there's a lot of information for these systems, okay, for these anatomical features that higher mammals have that need to be explained. Okay. And so the evolutionary community has to explain how those novel anatomical features can come about over time through mutations, selection, environment, gene flow, recombination, so on and so forth. Okay. Because what we see in terms of mutations, like beneficial mutations, the majority of them are reductive and functionally compromising to organisms. I'm not saying they all are, but the majority of them are. And we need real empirical explanations for these massive increases in phenotypic complexity that need to take place. And microevolutionary variations in creatures and species is not going to cut it. But if we're trying to just separate humans and chimpanzees, then yes, we can look to a massive difference. We would look to discontinuities, right? Continuities versus discontinuities. So in terms of discontinuities, we can look to the Y chromosome, which is what we're going to look to here. These massive differences in the Y chromosome in all the great apes. And you're going to see near the end, when we get to that these papers that have come out recently, okay, they actually strongly confirm what I've been saying on the biblical model of ancestry. But Erika is going to pretend that this data supports her position. No, the Y chromosomes are all incredibly different within the great apes. Okay. And she's going to say, well, if you're to be consistent, you can't have gorillas and chimpanzees. You'll see this is kind of near the end. She builds it up a lot till the end. Okay. I kind of appreciate how she puts these videos together because it's like a suspenseful movie. She slowly builds her way up to what she thinks is the grand slam, the grand finale. Okay. The pivotal point in the story. And so she goes on to say, well, now to be consistent, you got to say gorillas and chimpanzees are not related, or gorillas, chimpanzees, and orangutans, because all their Y chromosomes are incredibly different. Well, I've been saying that exact same thing for years now, since I've been putting forth my model. So creationists that would argue for all your great apes, except for humans being related, I would disagree with that. And I've been pointing out for a while now that the Y chromosome dissimilarity in the great ape family actually refutes that notion. And so we have gorillas already as their own created kind. So yeah, I don't have to force fit anything in. I've always said that the gorillas are their own kind. The orangutans are their own kind. Okay. And humans are distinct in the sense that they were created just in two. God created two people, Adam and Eve. That would restrict genetic diversity right off the bat. But animals, he created in bulk. So already we have something there to consider that's important, that we will discuss as we move along in this video. Okay. And so when you actually look at the Y chromosomes, you're going to see that your chimpanzee and bonobo Y chromosomes are still a lot more alike, even in light of your sperm competition and mating habits. We can explain the bonobo and chimpanzees being related to a common archetype. I'm not going to get into incredible detail on that in this video, okay, as we're already close to the hour mark. But your human Y, there's entire gene families missing. You'd have to explain the evolution of entire gene families, not just gene loss. So there's some intense changes that need to take place here. So when you actually look at this visual, you can see that, yeah, this is consistent. Gorillas are their own kind. Your orangutans are similar enough to where they're their own kind. Your humans definitely distinct. They're their own kind. And chimpanzees and bonobos go back to their own kind. When it comes to the human Y chromosome, I mean, heterochromatin, this densely packed piece of DNA, mainly comprising repetitive sequences like satellite DNA, which is very functional and beneficial to humans. Okay, that's entirely missing from what it seems in chimpanzees and also in bonobos. Okay, so this is just a general overview of the Y chromosome. So the point is, when Erika, when she's going to say near the end of her video that, well, now gorillas and chimpanzees can't be the same kind, but I've never said that they were the same kind. So, you know, if we're going to argue against my model, we have to argue against my particular model. Here we go.
In the early 2000s, we found out that humans and chimpanzees are 98.8% similar when looking at coding base pairs, and around 95 to 96% similar when looking at the entire genome. For the record, that is more similar than lions are to tigers, African elephants are to Asian elephants, and
well, first, I think we're going to wrap it up here, but I've got a lot for this video to cover, so we're going to get part 2 really soon, and part 3 as well, because we want to get to the meat of this. But again, it's the differences that make all the difference. Okay, so if considering protein coding, non-protein coding regions of the genome in its entirety, humans and chimpanzees are 95%. Well, who cares? Humans and banana plants are 50% the same, apparently. Go pick up a banana and put it next to a human and a chimpanzee, and you're going to be flabbergasted. 50%? Wow, that much? And yet humans look a lot more like a chimpanzee than they do a banana plant. So that's not really a huge surprise. But again, it's the differences that make all the difference. We can explain the similarities. So yeah, if creatures are very similar in certain areas, well, we would explain that in terms of common design. We can explain the similarities, and largely the evolutionists can as well. It's agnostic to the it's non-differentiating evidence. We need discriminatory evidence. That's where the massive dissimilarities come into play, because that, I would argue, only one model can explain, or only one model can explain the best. We all have our presuppositions and worldviews, so we're all going to have rescue devices from time to time. But are they good rescue devices? What's the most parsimonious explanation? What's the best rescue device here at play? Okay, and again, when it comes to animals, they were created in bulk. They were created at the ark, at Noah's Ark. Yes, God brought 2 of every kind, 7 of some, possibly 14. Okay, but at creation, God created animals in populations, in fully working ecosystems. He didn't just create 2 dogs, 2 cats, but he did create 2 humans. This is the biblical model. This is what the Bible says. He did create 2 humans, Adam and Eve. And so that would restrict levels of genetic diversity. With the animal kinds, you could have tens of thousands to millions right off the bat. So that's going to be a lot of genes floating around those populations. So animals are going to have a greater ability to diversify. And so it's not apples to apples. It's actually apples to oranges to say, well, humans and chimpanzees actually share a lot more in terms of their entire genomes than tigers and lions, even though we might say that tigers and lions go back to the same kind, the same archetype, felid archetype. No, that's apples to oranges. You got to take, because overall animals, there's always an exception to prove the rule, but there's always an exception to the rule, but it doesn't overturn the rule. And so you can't take 2 animals, or you can take 2 animals, compare them. But once you take an animal, compare it to humans, it's not necessarily apples to apples. Okay. So it looks like God engineered animal kinds with a greater ability to diversify. So yes, it would be expected then that lions and tigers may have a lot more DNA differences than, say, humans and chimpanzees, and yet they're related. Okay. But that's why the Y chromosome is very important. You're going to see throughout this series that Erika has not addressed this challenge. She really hasn't. And this data that has come out in these recent papers is truly fascinating, because it further confirms the biblical creation model. Actually, as far as I can tell from my reading of these papers that we're going to get into, based on these DNA sequencing technologies, okay, they've progressed quite a bit over the past several years. And so now we actually have this amazing opportunity to basically examine these chromosomes. We can examine and analyze them from end to end. And a lot of these genetic sequences that were difficult to sequence and decipher, okay, using older, less sophisticated DNA sequencing technologies, we can actually now decode those. We can understand what those pieces of DNA are, and we can now get a better analysis when comparing these creatures. Okay. So we have, I think it's right at the end of 2023, this is the paper we're going to get into, these scientific researchers, they've actually completed end-to-end DNA sequences of the Y chromosome for human and the great apes. Okay. And they use a gibbon Y chromosome is basically a primate outgroup. Okay. We're going to get into all that. And so now, when considering overall gene content, architecture, and size differences, the chimp Y, the new chimp Y, when compared to the human Y, is only 26%. It's less than 30%. Less than 30% the same. The evolutionary community has to account for those. They need to present a sophisticated, a detailed mathematical model showing how these differences can come about. So this paper specifically actually further strengthens the creation model, and it's not looking good for the evolutionists. And so where she titles it, the Y chromosome supports human evolution, no, it should be retitled, the Y chromosome supports separate ancestry. Okay, guys, so I'm really looking forward to this series, and I think we actually covered a lot of ground, because in this video we were able to cover the Dr. Andrew Snelling versus Dr. Lorence Collins controversy, accelerated decay there, and radiohalos. And we've gotten through about 5 minutes, which a lot of it's introduction, okay, to the topic. And I do appreciate that Erika sets the foundation for the video, which does comprise a technical topic. And this is going to be a lot of fun, because this is the most up-to-date series that you're going to find on the Y chromosome, because we are providing commentary on the latest research, the latest data that has come out on this issue. And so Erika is arguing that this Y chromosome data further supports human evolution, and she basically argues it dismantles separate ancestry. But you guys are going to see that it's quite the opposite. The new Y chromosome data further confirms biblical ancestry and further decimates human evolution. I would argue that it was preclusionary evidence before, but it's just established that much stronger. So the evolutionists are really gonna struggle with this one. I think they're just gonna have to posture. But guys, we're going to wrap it up here again. I think we covered a lot of ground. And so in the next video, we are really going to hammer through Erika's video here. And it is going to be thorough. So stay tuned. Guys, appreciate you joining me here. And God bless all.